Popular naval histories have spent more than a century portraying the Imperial Russian ironclad Novgorod as one of the worst warships ever constructed. To look at its blueprints is to look at a maritime absurdity, a heavy vessel that was perfectly, completely round. For generations, a famous story has dominated the legacy of this bizarre ironclad. The legend claims that every time the Novgorod fired its massive 11-inch guns, the recoil caused the circular hull to spin violently out of control like a top, leaving its crew dizzy, helpless, and drifting down the river. It makes for a spectacular historical punchline, but the truth is more complicated. The hull did not spin when the guns fired, although early trials revealed that recoil could force the individual gun mountings to rotate until their locking gear was strengthened. Far from a joke or a product of naval incompetence, Novgorod was a highly specialized attempt to solve a severe geographic restriction. Built to carry heavy armor and artillery into shallow water, the ship joined the defenses of Russia's vulnerable Black Sea coast. But its actual deterrent effect was never tested in combat. So how did a perfectly rational piece of engineering become a legendary maritime joke? And why would a major power deliberately build a warship shaped exactly like a saucer? To understand why the Novgorod needed to exist, we must rewind to the moment Russia lost its sea. In 1856, the Russian Empire suffered a humiliating defeat in the Crimean War. The subsequent Treaty of Paris imposed a devastating condition on the Romanov dynasty: the neutralization of the Black Sea. Russia and the Ottoman Empire were barred from maintaining major battle fleets or naval arsenals there, although each could retain a small number of light vessels for limited duties. For 14 years, the southern shipyards fell silent, and the empire's underbelly was left dangerously exposed to the sea. In October 1870, while Western Europe was consumed by the Franco-Prussian War, the Russian government seized the diplomatic opening to declare that it would no longer observe the Black Sea clauses. The restrictions were formally removed by the Treaty of London on March 13, 1871. The diplomatic break accelerated a defensive program that had already begun. By 1869, the Admiralty was examining shallow draft ironclads for the Black Sea approaches. But a political declaration does not conjure a navy out of thin air. During the years Russia was forbidden to build warships, naval technology had rapidly evolved. Their primary rival, the Ottoman Empire, had spent the preceding decade assembling a formidable, modern fleet of deep-water ironclads. If hostilities resumed, the Russian Navy would enter any conventional fleet engagement at a severe disadvantage. They had to adopt a purely defensive strategy. The Admiralty's immediate priority was securing the critical entry points to the empire's interior, specifically the Kerch Strait and the Dnieper-Bug estuary, which guarded the approaches to vital southern commercial centers and dockyards. To defend these geographic choke points, the Navy needed mobile, heavily armored coastal monitors, floating fortresses that could sit in the channels and shatter any Ottoman warship that dared to approach. But the Russian coastline contained a geographic trap. The crucial estuaries were exceptionally shallow. The original requirement demanded a draft of roughly 11 feet, although the completed Novgorod would draw closer to 13. The shallow draft requirement created a brutal paradox for conventional naval architecture. By the early 1870s, resisting modern naval artillery required heavy iron armor, while defeating armored opponents demanded rifled guns weighing dozens of tons. A conventional design strong enough to carry that load risked drawing too much water for the estuaries. One kept within the target draft would struggle to carry the required protection and firepower. The Admiralty needed a hull form that could spread immense displacement across a much broader waterplane. The leading shipbuilders of the era considered this an unsolvable riddle. You could not cheat the physics of displacement. But the Admiralty's most unconventional thinker, Admiral Andrei Alexandrovich Popov, realized the problem was not one of naval tradition. It was a problem of basic geometry. And Popov approached the crisis not as a traditional sailor, but as a mathematician. Admiral Andrei Alexandrovich Popov was a highly experienced naval officer who had commanded in the Pacific and served in senior naval positions. He watched traditional shipbuilders test variations on conventional monitor proportions, but every change intensified the trade-offs among draft, structural strength, armor, and concentrated gun weight. Popov concluded that they were modifying the wrong shape. The fundamental rule of naval architecture is displacement. A ship floats when it displaces a volume of water equal in weight to itself. To carry more weight without sinking deeper, the hull must enclose more underwater volume at shallow immersion. A broad waterplane can therefore reduce draft. Popov's insight was not that pressure moved outward, but that breadth created displacement without demanding the same depth. Popov stripped away centuries of maritime tradition and followed this logic to its absolute mathematical conclusion. If widening a ship increased its shallow water buoyancy, then the optimal hull would be one where the beam was exactly equal to its length. For a fixed perimeter, a circle encloses the greatest area, making it an extreme candidate for carrying heavy loads on a compact, shallow hull. Popov was not the first man to explore circular warships. In 1868, the prominent Scottish shipbuilder, John Elder, presented the Royal United Services Institution with a saucer-like circular concept, more a shallow segment of a sphere than the flat-bottomed cylindrical hull Popov would eventually build. Elder's proposal drew interest in Britain, but it was never adopted, and he died in 1869 before seeing any such vessel constructed. But Popov saw Elder's discarded mathematics as the exact key to Russia's salvation. He seized the concept and adapted it to the specific crisis of the Black Sea. He drew up plans for a vessel that was 101 feet long and exactly 101 feet wide. By proposing a flat-bottomed, entirely circular hull, Popov calculated he could cram nearly 2,500 tons of displacement into a vessel that drew just over 13 feet of water. That was enough buoyancy to carry massive 11-inch rifled guns and a heavily backed iron belt, roughly 7 to 9 inches thick, into waters barred to deeper conventional ironclads. It was a triumph of extreme specialization. The design was entirely rational, deliberately prioritizing the geometry of buoyancy over the hydrodynamics of movement. Popov fully understood that pushing a flat-bottomed circle through the water would generate horrific drag. But for a vessel designed strictly to sit at the mouth of an estuary and block an approaching Ottoman fleet, high speed was strategically irrelevant. The ship did not need cruiser speed, but it still had to deploy, steer, and hold a fighting position. Mobility was subordinate to armor and firepower, not irrelevant. The calculations proved that a round ship could theoretically solve the geographic trap. Now, Popov had to convince the Russian Empire to actually build a giant steel circle. When Popov's proposal reached the Russian Admiralty, it challenged almost every convention of contemporary naval construction. Surviving records show serious concern about propulsion and steering, although the dramatic scene of veteran officers confronting an unrolled blueprint is a reconstruction rather than a documented exchange. The central technical question was real. Could a hull without the directional stability of a conventional ship be controlled in current, wind, and sea? But adopting Popov's extreme geometry required a massive strategic trade-off. Procuring thick iron armor plates and massive rifled guns was staggeringly expensive for the Russian Empire's limited industrial base. Every imperial ruble the Admiralty spent on these highly specialized shallow water monitors was a ruble diverted away from building conventional, seagoing ironclads. Approving the round ships meant officially accepting that the immediate future of the Russian fleet would be entirely restricted to defending coastal mudflats. It meant sacrificing the ambition of projecting naval power out into the open Mediterranean in favor of pouring a fortune into a weapon that could only fight on its own doorstep. A doctrinal shift this severe, built around an entirely unproven and radical hull shape, would normally have been strangled by committee debates for years. Popov, for all his mathematical brilliance, could never have bypassed the conservative naval establishment on his own. To turn his blueprint into steel, he needed an institutional sponsor with untouchable authority. He found one in Grand Duke Konstantin Nikolaevich. As the younger brother of the Tsar and the General Admiral of the Imperial Russian Navy, Grand Duke Konstantin possessed absolute administrative power. Konstantin was also an aggressive modernizer who had spent the previous decade forcing the Russian fleet to transition from wooden sailing ships to steam-powered ironclads. When he looked at Popov's circular hull, he did not see a maritime abomination. He saw a ruthlessly efficient solution to a desperate political problem. The southern dockyards were completely exposed, and a powerful deterrent had to be put in the water immediately. Konstantin threw his full royal and political weight behind the architect's mathematical gamble. He provided an impenetrable political shield against the traditionalists, overriding their objections by framing the radical design as an urgent, highly effective coastal stopgap. If the traditional navy could not protect the estuaries with standard ships, they would let Popov protect them with geometry. By December 1869, the circular design had been selected for development. Model tests followed in 1870, the Tsar approved the project that October, and construction work began in April 1871 under the Grand Duke's protection. The first of these bizarre vessels was named Novgorod, in honor of one of Russia's most ancient and historically significant cities, a deeply traditional name bestowed upon the most untraditional warship in maritime history. With the project approved, Popov and a team of specialist engineers in St. Petersburg turned from theory to the mechanics of making the flat-bottomed iron saucer move, steer, and fight without capsizing or tearing itself apart under its own armament. The first and most severe challenge was directional stability. A standard warship relies on its length, its sharp bow, and its deep keel to track straight through the water. A flat-bottomed circle possesses absolutely zero natural tracking. Pushing it forward through the water is like trying to push a flat dinner plate across the surface of a swimming pool. The slightest asymmetrical pressure or passing current will cause it to veer wildly off course. To force the geometry to obey the helm, the engineering team devised an extreme propulsion system. With an aft direction defined for machinery and steering, they installed 6 independent steam engines, driving 6 parallel propeller shafts across the rear of the otherwise circular hull. This complex arrangement provided one distinct advantage: thrust-based steering. By throwing the propellers on the left side into reverse while throttling the propellers on the right side full ahead, the commander could theoretically pivot the Novgorod in place like a gear on an axle. But this maneuverability came with a severe engineering trade-off. The machinery was inefficient. The 6 propellers worked in disturbed flow. The boilers struggled to supply every engine, and the broad hull consumed immense power overcoming resistance. Much of the coal burned produced less useful thrust than Popov's calculations had promised. Once the propulsion was settled, the engineers had to arm the vessel, placing massive, rotating iron weapons near the outer edges of a round, shallow-draft ship would wildly unbalance the hull, risking a catastrophic capsize in rolling water. Popov's solution was to anchor the ship's offensive power dead in the center. His team designed a massive central barbette, a fixed armored ring rising from the middle of the deck, protected by layered wrought iron plating and heavy timber backing. Inside it, two enormous 11-inch rifled muzzle-loading guns, each weighing nearly 28 tons, sat on separate revolving mountings and could train independently. The weapons did not protrude through gun ports. Instead, they sat high enough to fire over the top of the iron wall. This central barbette system perfectly served the mathematics of the ship. It kept the crushing weight of the main armament balanced exactly over the ship's center of buoyancy, ensuring the saucer remained perfectly level. The armored ring formed a powerful central citadel, shielding the bases of the guns and much of the vital machinery and magazines below, but it was not literally impenetrable. However, keeping the vessel extremely shallow required ruthless weight-saving measures high up on the superstructure. To avoid the massive weight penalty of adding a fully enclosed armored roof, the barbette was left entirely open at the top. The trade-off was absolute exposure. While the iron ring protected the ship's vital internal organs against direct horizontal fire, the gun crews operating the turntable were left completely vulnerable to the freezing coastal weather, the chaotic spray of the sea, and the lethal threat of plunging enemy shells arcing down from the sky. The plans were complete, but assembling the massive iron hull was beyond the capability of the Empire's southern dockyards. To build the vessel, Popov would have to build it twice. The Russian Empire of the 1870s was a vast, largely agrarian expanse. Its heavy industrial capacity, the massive foundries and forges required to roll 11-inch iron armor plates and construct complex steam machinery, was overwhelmingly concentrated in the northern dockyards of St. Petersburg. But the Novgorod was desperately needed 1,000 miles to the south, on the shores of the Black Sea. Under normal circumstances, a newly built warship would simply sail from the Baltic Sea, down through the Atlantic, and into the Mediterranean to reach its post. But a low freeboard circular monitor with enormous hydrodynamic drag was ill-suited to a long ocean passage around the European continent. Such a voyage would have been slow, hazardous, and strategically impractical. The Admiralty was forced to treat the most advanced warship in its fleet like a colossal iron jigsaw puzzle. Construction began in St. Petersburg on April 13, 1871. Shipwrights provisionally assembled the iron framework and hull components, checking that the unprecedented circular structure fitted together correctly. By the ceremonial keel laying on December 29th, the trial assembly was already substantially complete. Then they dismantled it for shipment south. What followed was one of the most grueling logistical operations in 19th century naval history. Piece by piece, the disassembled iron hull, machinery, and armor were loaded onto railway cars and hauled south toward Odessa. The oversized boilers could not pass the railway clearances and traveled separately by sea from the Baltic. From Odessa, most components continued by barge to the Admiralty shipyard at Nikolaev, where widened slipways had to accommodate the extraordinary 101-foot beam. A second workforce then began reassembling Popov's Iron Circle. Despite the immense strain on Russian logistics, the southern shipyard succeeded. On June 2, 1873, May 21st by the Russian old-style calendar, the Novgorod slid down the slipway and entered the water. News of the launch quickly reached Western Europe, where the bizarre circular vessel, now affectionately dubbed a Popovka by the Russians, was met with immediate derision. The British press, accustomed to the sleek, globe-spanning ironclads of the Royal Navy, openly mocked the saucer-shaped warship as the product of eccentric Russian incompetence. But this early reputation was forcefully challenged by a foreign observer whose opinion carried untouchable weight. Sir Edward Reed, the highly respected former chief constructor of the British Royal Navy, traveled to Russia and personally inspected the Novgorod. When Reed returned, he wrote a series of letters to the Times of London, forcefully defending Admiral Popov's creation against British mockery. Reed did not claim the vessel was a capable ocean cruiser. Instead, he validated Popov's true intent. Reed argued that for its highly specific defensive purpose, the circular hull was a brilliant piece of engineering. He confirmed that the ship could carry massive firepower on a remarkably shallow draft, and noted that during its early trials, the strange propulsion system maneuvered the ship efficiently in the calm waters of the harbor. The Novgorod was finally in the water, and its initial harbor trials seemed to vindicate Popov's radical blueprint. But the still waters of the shipyard were not the chaotic currents of the Dnieper River. In 1877, the strategic crisis that had birthed Admiral Popov's radical design finally arrived. The Russo-Turkish War broke out, and the Imperial Russian Navy was called to defend the southern coast against the encroaching Ottoman fleet. The Novgorod was assigned to the defense of Odessa. That wartime station should not be confused with the broader mission for which the class had been conceived, protecting approaches such as the Dnieper Bug estuary and Kerch Strait. The ship's most revealing gunnery trials had already taken place in November 1874. The circular hull did not spin when the two 11-inch guns fired, and the vessel proved remarkably steady under recoil. The real defect was that inadequate clamps and locks could allow recoil to rotate the individual gun mountings. The gear was strengthened, and the problem corrected. The famous legend later transferred that real failure to the entire ship. Strong currents and poor steering could still wrench the vessel off course, but even the most dramatic river-spinning stories remained disputed. Outside sheltered water, the price of the circular hull became unmistakable. With little natural directional stability, ineffective rudder placement, high resistance, and machinery that did not deliver its expected power, Novgorod was slow to answer the helm and difficult to keep on course. Currents and wind could magnify the problem, and contemporary reports describe at least one voyage on the Dnieper in which the ship turned involuntarily. Later retellings may have exaggerated the episode into prolonged spinning. As built, Novgorod managed roughly 6.5 knots, not 7. Its boilers could not supply all 6 engines efficiently, and the outer pair contributed little useful thrust. Those 2 engines and their propellers were removed in 1876 to 77, after which speed fell to about 6 knots, while coal economy improved only modestly. The problem was not one single vortex behind the stern, but the combined penalty of hull resistance, poor steering geometry, steam limitations, machinery defects, and propulsive interference. Despite those defects, Novgorod remained heavily armed, shallow draft, and unusually steady as a coast defense platform. It was not an ocean cruiser, but its mobility defects were severe even within its intended role. Yet the Ottoman fleet never attacked Odessa while Novgorod was stationed there, and the Monitor never fired its main guns against an enemy vessel. Its combat value and any deterrent effect therefore remain unconfirmed. Russian mines, coastal batteries, small craft, geography, and Ottoman operational priorities all shaped the threat. Anchored in position, Novgorod could present a difficult armored target with powerful 11-inch guns, but it was neither unsinkable nor guaranteed to defeat every ironclad afloat. Following the conflict, as Russia rebuilt a more conventional Black Sea fleet, the specialized Monitor became progressively less useful. It made only limited seasonal cruises, spent long periods inactive or in reserve, was struck from the Naval Register in 1903, and was sold for scrap in 1911. By the time the breakers' torches dismantled the giant iron circle, The true story of its design had already been overwritten by a powerful historical myth. As the 20th century dawned, naval history began to be codified by men who valued the dominant, ocean-spanning battleships of the era. The most influential voice was Fred T. Jane, the founding editor of the famous Jane's Fighting Ships Reference Guides. Jane, like many Western observers, looked at the Novgorod and saw only a clumsy, slow, unnavigable aberration. In his 1899 book on the Imperial Russian Navy, Jane repeated a dramatic account of the circular ships being whirled around by the Dnieper current and leaving their crews disoriented. He did not, however, claim that firing the guns spun the entire hull. That fusion appears to have emerged in later retellings. Over decades of retelling, the nuance of the Novgorod struggle against the river tide was entirely lost. The story mutated. It became the legendary, hilarious myth of a ridiculous warship that spun violently like a top every time it dared to fire its own guns. The name Popovka ceased to be a testament to the engineer's ingenuity and instead became a permanent shorthand in naval textbooks for eccentricity, incompetence, and the worst excesses of maritime design. Admiral Popov passed away in 1898, highly decorated by his empire, but historically doomed to be remembered as the man who designed a maritime joke. Yet, when historians peel back the layers of mockery, a different legacy emerges. Novgorod was not the worst warship ever built, but a product of extreme specialization. Popov found a way to place heavy guns and armor on a remarkably shallow draft, while the trials exposed penalties in speed, steering, endurance, and operational flexibility. He did not forget that the sea obeys mathematics. He discovered that a warship must satisfy all of it: buoyancy, resistance, control, machinery, weather, and war at the same time.